Okay, here we go. This is the last one brought to you by the 69th Drone Detachment today. It's going to be a little closer look into your DJI Air Unit. And like I said before, no matter what tricks they're doing and what proprietary stuff they're basically doing a certain type of modulation and a certain type of frequency hopping. And there may be some proprietary stuff in there that makes it unique. And maybe even better in improvements. That's gonna, you can always improve the wheel. But this is how the basic one works. And this could, like I said, this could all be going on one chip or a series of chips, processor chips, this, and then some RF, micro miniaturized RF integrated circuits or whatever. But regardless, in the old days, it used to be separate pieces of gear with separate components in them. But now it's just all on one little chip. It's got to be because we just get it on our drone. So real quick, just to go over this. And if anyone's interested, then we'll start doing it in more detail. But this is the modulator. This is a frequency hopping spread spectrum modulator. Well, actually, I missed one part. Shoot, I got these two inputs. And I forgot about the spread spectrum part. We got to spread this basically and encode this. So at these inputs, what could happen is you'd really take a signal input and you'd put it in through like a RS encoder. Then you'd put it through maybe like a symbol interleaver. I think is how I remember them doing it back in the old days. These used to be cards that we used to have to change or circuits we used to have to troubleshoot. And then you'd go into like some number. This is the part that's proprietary, man. They call it AIr. Some number of degrees. Symbol modulator, basically. And it takes these coded symbols and codes them into different various levels and possibilities, and that could vary. And then they take those, and this is like a symbol for like logically mixing stuff at a logical level rather than an RF level. And then they take a PN encoder here, and I think in most cases they go at least 32 chips are what they call instead of bits. These are symbols when they're encoded. These are bits when they come in, and these are chips that they're modulated with. It's funny, but that's a 32-bit, if you will, or 32-chip signal scrambler with a pseudo-random noise sequence, right? Pseudo-random bit sequence. And it could be truncated, and the shift register could be tapped and changed to make it go different ways that you wouldn't expect, so it's like coded even further. And that's what spreads it. That takes that data and it just spreads it out into a wide number of bits, that are going to make this modulator spread it all over the frequency spectrum. And so then there's your output from this little, I guess you might call it that part of it being the spread spectrum module, coding part. So it comes into this bandpass filter. Shapes the data, make sure it's going to get the right levels. You could either put it in here or here, if you already want to take care of the filter in here. You go to a serial parallel converter and you split that data off into I and a Q channel and I1 and Q1. And then this QAM, quadrature amplitude modulation, it's a constellation manager and constellation modulator. And it figures where there's a constellation. If you're looking at this as like amplitude and frequency, and there's a bunch of phase states and phase and amplitude states within the different rotations of a modulated carrier that you could signify with data bits, right? And depending on how many of those you use, that might be proprietary, and how you map them in this constellation mapper. But in the end, you're breaking it out into an I or Q channel, in phase or a quadrature channel. You're taking it into an impulse modulator. And that modulator just takes this filter. It's like S1 is like a frequency hopping bin, like a shift register. That basically what it does is it can randomly, or it also can selectively tell us based on feedback from the DMod what's out there and what the signal seems to be fair. But usually they don't need to do that. That's too complicated. They put it into an impulse modulator, and that'll tell it where to shift ahead of time. Then they just take a finite impulse response, like a pulse shaping filter. And then, boom, there you got your data, your preconditioned data now, and it's coming in here, and it's basically has been modulated already, right? It's right here. And now you're taking it into a double balanced mixer. And what it does is you got an oscillator here. That's that symbol for an oscillator, like a sine wave. It's coming out one side of the oscillator is in phase, 0 degrees shift, or that's the I channel. The other's the Q channel reference, and it's 90 degrees out of phase. Now, here's another thing. You could do a bunch of different phase mixed states in here, too, to add more data density and more coding, and that could be proprietary as well. But in our case, all we're caring about is this is just standard way it works. And so you come in and you phase shift this. So you've got to, once you mix the data onto this local oscillator, you've now had this baseband kind of data at a lower frequency mixed with a higher frequency oscillator. You get the sum, the difference, and the two originals. You filter it out for only the sum. And now you got this high frequency modulated carrier. You put down that sigma as the sign for a universal sign for a summer, like a RF summer. So now you got a modulated I channel and a Q channel. They get summed together, and that's your modulator output. And that's going to your block up converter or your high power amplifier. And so there it is. I mean, they can try to be all secretive about it if they want, but this is how your basic thing works. And that's what's going on inside of that little chipset when you say, oh yeah, I'm just my VTX. And at some point, that's what's going on in that VTX. Whether you're DJI or whether you're anybody, they're all doing pretty much spread spectrum frequency hopping, and that's what this is. And using what they're doing, that's in addition to this QAM. That's the best way to code it. They could code QPSK or something that had a lower data throughput, but why? It'd be stupid. So it's pretty much got to be that or something even better. And there you go. Now you know. We'll see you up there flying. Once again, it's been brought to you by good old 69 Drone Detachment. See you later. Sponsor me, buy me a drone. Bye now.